Timeout. When we're being asked to graph a quadratic, this is using completing the square to get it into vertex form, so we're going to have to add and subtract the box on one side of the equal sign. So what I'm going to do is I'm going to rewrite this as y equals negative 2x squared minus 12x, and I'm going to go ahead and kick the negative 21 on the outside, right? Because we're going to work only on the one side of the equal sign. So I'm going to go ahead and factor out a negative 2, and that's x squared plus 6x. Now remember, I had to change signs here because I'm factoring out a negative 2, and that's going to give me negative 21 on the outside. I'm going to go ahead and add the box, and on the outside I'm going to have to subtract the box, right? Because if I had to add the box on the left side, I'd end up having to subtract it anyways. Inside the box goes half the middle term, so it's 3. Now, anyone know what happens to the 3 on the outside of the box? 3 on the outside of the box? Jacob. I have to multiply a negative 2 in because of this interaction here. So I'm going to go ahead and simplify the easy side, which is negative 2 parentheses x plus 3 squared. This becomes a 9. This becomes a negative 18. So I've got negative 21 minus negative 18, which becomes positive positive. So I end up with negative 3. You guys will be provided with graphs on the test, so don't worry about any sloppiness when it comes to drawing your axes. So I'm going to go to my vertex. Anyone know what my vertex of this parabola is? Nate? Negative 3, negative 3, right? Opposite intuition for x with your intuition for y, since x is inside parentheses. Negative 3, negative 3. I draw my vertex. Is it upward facing or downward facing, Dustin? It is downward facing. So it's going to do that. Now, for these problems, I'm going to ask you guys to actually make a table. So my vertex is negative 3, negative 3. Now, I need a really, really easy number to plug in. Really, really easy number to plug in. Chief? 0. So let's plug in 0. Thanks, Dom. 0. Now, plug smart. Don't plug into this. You're going to actually have to think for this one. Plug into this one. What happens if I plug 0 in for all the x's on this left side equation? What do I get? Kind of negative 21, right? 0 cancels, I get negative 21. Now remember, a parabola is symmetrical about the vertex, so where else is the number negative 21 going to appear? Ty? Negative 6. I need an axis of symmetry. Anyone know what the axis of symmetry of this parabola is? Chief? X equals negative 3. Remember, the axis of symmetry is a line, so make sure it's going to represent that line. And you do that. Okay, that's how you do number 44. Is it 45? Whoops. Okay, so let me backtrack. Backtrack here. Okay, so 44, the discriminant. Okay, so 44 here is 2p squared minus p minus 9 equals 0. So again, I'm going to go ahead and just make a little discriminant section here. Remember, the discriminant is b squared minus 4ac. So b squared in this case, well, b is negative 1, so it's going to be negative 1 squared minus 4a, which is 2, c, which is negative 9. So it looks like I've got 1 minus, this is 8 times 9, which is 72. But since it's negative and negative, it's going to be positive. So I end up with 73. Now, who knows what types of solutions we are going to get here? Chris? 2 real. 2 real soul. So now I'm going to go and find the values using the quadratic formula. So it's going to be p equals opposite of b, so negative 1 plus or minus the square root of, plug smart. Don't do the b squared minus 4ac. Again, what could I actually plug into that square root? Devin? 73. All over 2a. So I end up with positive 1, so 1 plus or minus root 73 over 4, and that's what p equals. All right. Okay, let's move on. Oh, I'm sorry. What's up? Okay. I love the undo button. Okay, we had 44, so we did 44, 45. Oops, yeah, 68. Okay, let me go to 68 real quick. Ah! Quadratic inequalities. Wait, who asked for 68? Okay, Nate? Okay, I'm going to do that one. I'm going to do another one. All right. Actually, can I do the other one first? Okay, so I'm going to do, let's see, how about 72 first, and then we'll come back to 68. So 72 is x plus 8 times 7x plus 1 is less than or equal to 0. So from here, because we're solving an inequality, we need to find critical numbers. Right? Critical numbers are where the function equals 0 at this point. The function is going to equal 0 at -8 and -1 over 7. Are there any questions as to how I got those two numbers? Yeah.
How do you get -1 over 7?
Okay, that was done through 7x plus 1 equals 0, and then subtract 1, and then divide by 7. Yeah?
Oh, yeah.
Okay, cool. So now I pump these into a number line. So -8 is on the left, -1/7 is on the right. I partition it down, and then I draw by my two functions, which are x plus 8 and then 7x plus 1. So a number that is smaller than -8, say negative, what, doesn't? -5 billion, sounds good to me. -5 billion into here gives me a negative number. -5 billion into here gives me a negative number. A number in between -8 and -1/7. We actually have to think on this one. A number between those two. What do you think, Dom? In between negative and negative. So -2 would work. So -2 into the top function would give me a positive. -2 into the bottom function would give me a negative. And then to the right of 1/7, you can choose a billion or 0, whichever one works for you. Looks like we're going to get double positive. Now, with a quadratic, it's always going to alternate, so it's just something that it does. Or most of the time it's going to alternate, sorry, not in 68. So my final intervals, because I'm multiplying these two together, negative times negative is positive, positive times negative is negative, and then double positive will get me positive. So since I'm looking for the interval at which this is less than 0, I'm looking for which one, positive or negative, Ty? Negative. So I draw my interval notation. It starts at -8 and ends at -1/7. And because I am including, I'm going to draw hard brackets. So that's my answer. Okay, Nate, to answer your question, yours is n plus 5 quantity squared is less than or equal to 0. All right, so this is n plus 5 times n plus 5 is less than or equal to 0. Yeah? Okay, Nate, do you know what the critical numbers of this function is? It's just -5, right? There's only one. And so what's happening here is that at -5, something kind of funny is happening. So we got n plus 5, and actually squared. Let's make it squared, because there's two of them, right, Nate?
Yeah.
Okay. Give me a really, really big negative number. -30. That means I would get -25 into here, right? What's -25 squared? Positive number, right? So this is positive. And in fact, if I chose -7 trillion, if I square it, what does it end up becoming? It ends up becoming positive. So it's positive all the way. If I choose a positive number, like 10 or 10 million, if I square a positive number, what do I get? Positive. So it's always positive. So we're looking for where this thing is going to be negative. So where is it negative? Never. So it's... Yeah? Cool. All right. So that was 68. Uh, 206. That should not have existed. I don't know where 206 came from. 134. Okay. Well, Luckily, there aren't 206 problems on this thing. 134. Ah, I should recognize my own handwriting. That's mine. Okay, 134 here. They're asking you to write the equation of the ellipse. They give you the vertices. And they give you 13, 8, and then 3, 8. And they give you the foci. That's the focal coordinates, by the way. 11, 8, and then 5, 8. Now, what is the first thing that I always recommend you guys do when writing the equation of an ellipse or a hyperbola or whatnot, Chris? Graph it. Draw a picture, because if you don't, start calling you Tim Westwood. All right? So, 13, 8. Let's call this 13. Let's call this 8. So that's about right here. 3, 8 is about right here. And then 11, 8 is right here. That's a foci or focus. And then 5, 8 is right here. Anyone know what type of ellipse this is going to be? Is it going to be vertical or is it going to be horizontal? What do you think? Sean, what do you think? Is it going to be vertical or horizontal? Horizontal, because the foci is always on the major axis. Good. So it'll look something like that. Now, to find the center of this thing, I have my coordinates here. This is 3, 8, and then 13, 8. What formula should I use to find the center of this thing? Michael? Midpoint. So let's go ahead and do that. So the center is going to be 13 plus 3 over 8, 8 plus 8 over 2. Sorry, that should be a 2. That's 16 over 2, so my center is going to be 8, 8. So, can we write out the bulk of this equation already? Can we write out the bulk of this equation already? Yeah. Dustin, what does it look like? Not y equals, it's an ellipse, so it's going to be x equals 1. All right? Now, what is that distance right there? Between 3, 8 and 13, 8. What is that distance? Devin? It's 10. Which means that a equals 10, which means a squared equals 100. Anyone know where this 100 goes? Under which value? X or y, Chris? X. Because the major axis is sideways. Max? Is it? What does it say? It says 25 and 16. Oh, you know why? Sorry. He's right. Because if the distance is 10, then this distance is 5, which means that a equals 5, which means a squared is 25. Sorry, it is 25. Because the distance from one axis to another, or from one vertex to the other, the distance is 10, which means that the distance from the center to that vertex is 5, which means that a equals 5. And if you square a, 5 squared is 25, which means it's 25 here. Yeah? And then to get the b value, we're going to use CAB formula. So it's going to be c squared equals a squared, which is 25, minus b squared. But we need to find out what c squared is. Well, the distance between the center and this focus here, this is 5, 8, and this is 8, 8. What's the distance right there? 3. So it's going to be, so c is 3, which means c squared is 9. So 9 equals 25 minus b squared. Subtract 25 from both sides. We get negative 16 equals negative b squared. B squared equals 16. This number becomes 16, which is what they got, right? Okay. A little bit of an involved problem, but it's that's gonna make sound. All right, so that was 134. Okay, let's take a look at 145. Okay, good question. 145. Okay, vertex is at 1, 1, focus is at 7, 8. We're writing the equation of a parabola. First thing I have you guys do is draw a picture of it. So we go to 1, 1. The focus is at 1, 7 over 8. So is the focus above the vertex or below the vertex? That's the only thing you guys got to know. Is the focus above or below? See, I'm at 1, 1. My focus is at 1, 7 eighths. Chief? It's above? Alex? It's below. 7 eighths is less than 1. So, let's use some sense here. What's the only way this parabola can possibly open up? What's the only way that this parabola can possibly open up? Taylor? Down. Which means that this is a y equals parabola, and it's going to be negative because it's facing down. I have no idea what that is, but I know what my vertex is. It's going to be x minus 1 squared plus 1. Right, and the 1's came from the vertex. I know that it's a y equals because it's downward facing, and I know that it is negative because it's downward facing. All right, now we got to figure out a. Well, the distance, I'm going to go ahead and blow up this parabola real quick. If the distance from from my vertex to the focus is 1 to 7 eighths, what's the distance between them? Don? Okay, it's 1 until 7 eighths, so the distance is going to be, Michael? 1 eighth. And that is c, right? So we say c equals 1 over 4a. Well, in this case, c is 1 eighth. So go ahead and just cross multiply. See what you get. 4a equals 8, a equals 2. You pump 2 into here, but since it's negative, it's going to be y equals negative 2, x minus 1 squared plus 1. All right, that's 145 for you. All right, let's move on to 150. We're getting towards the end. Okay. Okay, the focus is at 3 over 2 comma negative 4, and the directrix is x equals 5 over 2. Okay, so let's go and just draw a picture of this thing. The focus is at 3 over 2, so that's 1.5 comma negative 4. And the directrix is 5 over 2. 5 over 2 is 2.5. So if this is 1.5, then let's call this 2.5. I'm going to draw my directrix. What is the only way that this thing can open up? Only way this thing can open up. Devin? No, it's not going to open up downward. Kenna? It's got to open up to the left. All right. How do I find the vertex of this parabola? Dustin? It's exactly the center between the focus and the directrix. So let's call this 5. Let's call this point here 5 over 2 comma negative 4. Because this here is 3 over 2 comma negative 4. So we have to use midpoint formula for that one. So I know my y-coordinate is going to be negative 4. But let's find out our x-coordinate. That's going to be 3 over 2 plus 5 over 2 over 2. That's 8 over 2, so that's 4 over 2. That should be 2. So my vertex is going to be 2 comma negative 4. Since this is a left-facing parabola, it's going to be x equals some kind of negative a, and then y plus 4 squared minus 2, or sorry, plus 2. Now I need to figure out a. Well, the distance between my vertex, which is 2, and 1.5 is 1/2. So that's C, so C equals 1/2. So 1/2 equals 1 over 4a. Cross multiply, 4a equals 2. A equals 1/2. So it should be x equals negative 1/2, y plus 4 squared plus 2. Questions on that? On where any numbers came from? Michael? Okay, that is because I'm going to go ahead and just draw the parabola one more time. Okay, Michael, you okay with this? Being the parabola? Okay, I'm going to go and just expand the focus a little more. Because this vertex, are you okay with the vertex being 2, negative 4? And then the focal coordinates they gave you were 3 over 2, negative 4. 3 over 2 is 1.5. So the distance between 1.5 and 2 is 0.5, which is 1/2. And so that distance is C. Okay. Chief. The vertex and the focus. Or the vertex and the directrix, it doesn't matter, because the distances are the same. Okay, let's do the last problem here, which is not the last problem, 158. Okay. We've got a quadratic system. Okay, so 158 is going to be negative x squared plus 2. Yes. 5. Sorry, not that that's any better. Okay, who asked for this one?
Me.
Okay, so Gabby, just like any system, we're trying to solve for x and y. I'm going to go ahead and multiply the top by negative 1 to get x squared minus 2y squared plus 14x plus 7y plus 49 equals 0. And I have a funny feeling I wrote this problem down incorrectly. Let me see here. The bottom one for the 61. 61. Okay, so Gabby, remember, you can only solve for one variable at a time, so my objective is to eliminate x. When I multiplied by negative 1, it changed all the x's signs. So, see how the x squareds are now going to cancel each other out?
Yeah.
I end up with 3y squared. See how the negative 14 and the positive 14 are going to cancel each other out? Yeah. I end up with negative 16y plus 7y, which is negative 9y. And then 61 minus 49. In this case, it would be negative 12 equals 0. I'm going to go ahead and divide everything by 3. Make it easier because they all have a common factor of 3. So y squared minus 3y minus 4 equals 0. I factor this out. Looks like it's going to be y minus 4 times y plus 1 equals 0. Yeah? So y equals 4. Y equals negative 1. So that's only half of the problem. Oh boy, some of this is gross. You good, Gabby?
Yeah.
Okay, so now I'm going to take it and plug it back into one of these. So I'm going to choose the bottom one, which was easier. So I'm going to go ahead and rewrite the bottom. That was, actually no, they're both equally gross. So I'll rewrite the top. Actually, no. Gabby, can I erase some of this stuff?
Yeah.
Okay, like all of this?
Yeah.
All of this is gone?
But do we have to plug in like the same number? Like, do we have to plug in 4 and then we have to plug in negative 1?
Yes, we have to plug in 4 and then we have to plug in negative 1. You think you can handle that, or?
Yeah.
Okay, so do I need to keep going?
No.
Okay, cool. All right, so let's go ahead and finish up that last problem. Should be a sum and product of roots. 161. Okay, why don't we do number 160. Who asked for 161? Okay, can I do 164 instead?
Sure.
I think that'll make a little more sense. Because that way I can knock two birds out with one stone. Okay, if we're writing the quadratic with these roots here, again, the setup is easy. It's just x minus one of the roots, so x minus negative 4, and then x minus negative 2 over 3. From here, you're just going to FOIL it, but let's go ahead and simplify what we can. We know that the left is going to be x plus 4 because minus and negative is positive. Remember the right side when I told you you had a fraction? What should you do whenever you have a fraction that's a root? How do you eliminate that denominator? Anyone remember how to do that? Chief? Multiply by the denominator. So multiply by 3. That goes into here. That's 3x. And then negative is positive. 3x plus 2. And from here, Gabby, you just FOIL this thing out. This is 3x squared plus 2x plus 12x plus 8. Combine your like terms, so that's going to be 3x squared plus 14x plus 8, and that, remember, equals 0, and you're done.
So I could just like plug it into that like formula and then. Okay.
No, you just unfoil it and then you foil it back.
Okay.
Max.
So when you divide -2 times 3, you get -2.
Yeah, but remember, Max, because you're subtracting a negative, they turn positive.
Yeah, but then how do you get the 3x?
Because the distributive property says I have to multiply to both.
Oh, you multiply them out.
Okay, cool. Go ahead and keep working, and then we'll answer maybe 5 more questions before the period's over. All right, 166 we'll do first. And the problem is -2 plus 5i over 4, and then -2 minus 5i over 4. Now these are the roots of the quadratic function here, so what I'm going to do is I'm going to go and write them in. X minus, parentheses, -2 plus 5i over 4 times x minus -2 minus 5i over 4. First thing I'm going to do, since I'm dealing with roots that have fractions in them, I'm going to go ahead and multiply everything by 4. So when I distribute that, I get 4x minus -2 plus 5i. And then here, I get 4x minus -2 minus 5i. Okay, remember, do not distribute the negative and make a trinomial times a trinomial. You're going to make your life really, really crazy, and you don't want to do that. Just FOIL normally. 16x squared. Okay, 4x times this thing. It's a negative thing, so it's going to be negative 4x times this thing. So -2 minus 5i. Again, the negative thing times 4x is another negative 4x times -2 plus 5i. And then a negative thing times a negative thing is a positive thing, and that thing just so happens to be -2 plus 5i and -2 minus 5i. All right, so let's go ahead and distribute and clean this thing up. This is 16x squared. That's a piece of cake. I get 8x squared. I'm sorry, 8x, positive 8x, plus 20xi. I get positive 8x again, negative 20xi. Now, what should I be expecting to happen to my I terms? They should always cancel, right? If I didn't cancel, I did something very, very wrong. This is 4. It's a conjugate, es un conjugado, so I don't need to multiply the outers and the inners. I just need to multiply the first and the last, so that's minus 20i squared. What is I squared? -1. So that becomes positive 20, so that is plus 24. What happens to the I terms? They actually do cancel. These two can combine, so I get 16x squared plus 16x plus 24 equals 0. Yeah? No, just leave it. All right, let's see here. That was 166. Let's go ahead and tie. Oh, it does? Thank you. So this should be 4. So it should be 29. 29. Thank you, Ty. All right, so that was 166. Let's back down to 138. Okay. Looks like we are writing the equation of an ellipse. So the vertices are going to be 10, 2 and 10, -8. And then the foci are going to be 10, 1, 10, -7. All right, so what is the first thing I expect you guys to do? Draw a picture, otherwise start calling you Tim Westwood. So 10, 2 is right here. 10, -8. Whoa. I'm sorry. 10, -8 is down here. So this is 10, -8. This is 10, 2. Okay, so the foci are at 10, 1 and at 10, -7. What type of ellipse is this going to be? What type of ellipse is this going to be? Michael? It is vertical. That's correct. So it should look kind of like that. All right, so to find the center of this thing, I used midpoint formula. So I'm going to go, let's see, 10 plus 10 over 2, comma, 2 plus -8 over 2. Well, my center is going to be 10, comma, this is -6, so 10, -3. So the first part of my equation is going to look like this. X minus 10 squared plus y plus 3 squared equals 1. And that's going to be over something. Okay, well this thing here, this is 10, -3. So all I need to know now is what the distance between the center and that vertex is. What's the distance between -3 and -8? Max?
5.
It is 5. So A equals 5, which means A squared equals 25. Now, here's the important question. Where does A squared go? Y-axis. And this is B squared, right down here. So what is the distance between, see, whoops, there's this thing. This is 10, -7. What is the distance between 10, -3 and 10, -7? What's that distance going to be? Devin? 4. So that means that C equals 4. So C squared equals 16. So I say 16 equals A squared minus B squared. Negative B squared is going to equal -9. B squared equals 9. So, bam. Duh. That's yes in Russian. Okay. 138 is dead. Oops. Yeah, Chief. To find the vertex, to find the center, it's probably a good idea. Okay, 61. Move back. Jeez. Okay. Okay, because of this problem here, I'm going to have to convert into vertex form. Who asked for 61? Okay, Emily, so here we go. Y is greater than or equal to, I'm going to factor out a -4, Emily, all right? So I got x squared minus 4x. Do you know why it's minus, Emily? Yes? Back the 15 out here. I'm going to add the box. I'm going to subtract the box. Now, what happens to the box on the outside of the parentheses? Chris? Multiplied by -4. So this is y is greater than or equal to, that's negative 2 and negative 2. So I got negative 4 parentheses x minus 2 squared. Let's see, that's 4 times negative 4, that's negative 16. So negative 15 minus negative 16 is going to be positive 1. Okay, Emily, since this is an inequality, I don't expect you to make a table. Just know where the vertex is. Emily, do you know where the vertex of this problem is? 2, 1. And which way is it facing? Down. Okay. All right. Now, y is greater than this thing. So, are we shading above the vertex or are we shading below the vertex? Julia, what do you think? Are we shading above the vertex or below the vertex? Y is greater than. Above is correct. All right. Okay. That was 61. Let's knock out 43. 43 is the quadratic formula. First, find the discriminant. Okay, the discriminant is b squared minus 4ac, so that's b squared minus 4ac. So that's 4 minus 20. So that is negative 16. What type of solutions do I have here, Chris? 2 imaginary. Okay, so now I plug it into the quadratic formula, so it's it's going to be x equals opposite of b, so negative negative 2 plus or minus the square root of, plug smart. What do I plug into the square root value, Angelica? Negative 16, and we'll simplify that over 2 times a. Well, that is positive 2. What is the square root of negative 16? Ty? 4i, so it should be 2 plus or minus 4i over 2. I can reduce that because they're all even, so I get 1 plus or minus 2i. Yes, Gabby?
Because you wrote like plus or minus, you don't have to write it like twice, right?
Nope. Nope. The two imaginary solutions you're dealing with are 1 plus 2i and then 1 minus 2i.
Okay.
But since you did plus or minus, that's kind of like a 2 for 1, you know, like when they have shampoo and conditioner in the same bottle. All right, 39. Okay, another quadratic problem here. So 4x squared plus 4x plus 5 equals 0. So again, discriminant. B squared, 4 squared minus 4ac. 16 minus, let's see here, this is 20 times 4, 80. What is 16 minus 80? 64? So what types of solutions do I have here, Ty? 2 imaginary. So I get x equals negative b plus or minus the square root of, plug smart, what goes inside there, Chris? Negative 64 over 2a. So that is negative 4 plus or minus, what is the square root of negative 64? Chief? 8i over 8. Now I can reduce this. I should reduce this. In fact, it's not optional that I reduce this. So this is going to be all divided by 4. So that is negative 1 plus or minus I over 2.
Isn't it 2i?
I'm sorry, thank you. No, I'm dividing by 4. Because I can't divide by 8 because, let me back this thing up here. I'm dividing by 4 because 4 is the smallest number that I have. So this is really negative 4 over 8 plus or minus 8i over 8. Now I could simplify it this way, but this will be negative 1/2 plus or minus I, that's fine, but the book or the answer sheet will prefer that you keep a common denominator. Right, so that means -1 plus or minus 2I over 2. That's 39. 30. Okay, 30 is n squared plus 4n plus 57 equals -7. This is completing the square. That's what they're asking you to do. So I'm going to subtract 57 from both sides. So I get n squared plus 4n equals, this is -64. I'm going to add the box to both sides. Now I'm adding the box to the other side because I'm working on two sides of the equal sign. There's a 2 in here and a 2 in here. That's a piece of cake. N plus 2 squared equals, that's 4. So -64 plus 4 is -60. I'm going to take the square root of both sides. That's n plus 2 equals plus or minus. This is 15 times 4. So it's 2I rad 15. Yes? Duh? All right, minus 2 from both sides, so n equals -2 plus or minus 2I rad 15. Who asked for that question? Beth, you good?
Yeah.
All right, cool. Very good.